Hey everyone, welcome to our number talk today. The problems that we're going to talk about today are focusing on multiplication. And the first problem that I'm going to put up on the board is 9 times 12. And at this point I would ask the students to think about ways that they would solve this problem and ask for volunteers to share their strategies. And I know that they might have multiple strategies. And so I would ask one student to come up and show how they would solve this. And I think one way a student might come up with would be a strategy they've learned to make the 9 into a 10. Because 9 times 12 is challenging to do in the head, but 9 is very close to 10. And if they add 1 to 9 and make it 10, they can multiply it by 12 and get 120. The next step for the student might be where they slip up if they forget that the 1 that they added to the 9 is also being multiplied by 12. And since that 1 is also being multiplied by 12, which equals 12, then what they subtract from their final answer to get it back to where it was supposed to be is not just 1, but 12. And if they do that, they will end up with 108, which is the correct answer. And if that error was made, I would just use it as an opportunity to talk through the distributive property that was used here as 9 plus 1 times 12. Reminding them that the 12 goes to both numbers that are being added together. Another strategy students might use is to use a distributive property in another way, thinking about the tens place and the two ones in this number as separate, able to be separated and multiplied individually by the number 9. And if they multiply 9 times 10 plus 2, knowing that 10 plus 2 equals 12, they can see that it's much more easier to multiply 9 times 10, which equals 90, and 9 times 2, which equals 18. And then they're left with 90 plus 18, which they can add together to get 108. Similarly to this one, an error they might make if they forget to draw their parentheses or forget the order of operations, they might multiply the 9 by the 10 to get 90 and then add the 2, which would give them 92. But that would just be another opportunity to point out the distributive property in that the 9 is shared with both of those numbers being added together. A third way students might come about this problem, solving it, is since it's not a very big number, both of them are fairly small, they could solve it by drawing a model, such as an array. And if they draw a group of 9, they might draw the same group 12 times to show 12 groups of 9. And doing that, they would come up to 12 and count them all together, which would give them 108 dots. That would be another example of students solving this problem, which would work for this problem since it's not very big, and it would show how it works of 9 times 12. So that's our first problem. The second problem that we're solving is very similar. It is 99 times 12. And I would ask the students to look at this problem and think about what strategies they would use for this one. Would they use similar strategies, the same strategies, or do they have other strategies that they can think of? One that I think students would think of, especially after the first problem that we did, would to see that this 9 is really close to 10, and that 99 is really close to 100. And 99 plus 1 equals 100, so they could do the same thing either in their head or drawing it out as a distributive property, multiply that 100 by 12. And if they have 100 times 12, that would give them 1,200. And that 1 being multiplied by 12 would then need to be subtracted from their final answer, and that would give them the final answer of 1,188. That would be another great way for them to do it, using that mental math strategy of making a 99 into an easier number, 100. And that could be done if this was 98 or 97, but 99 is especially easy because it's only one away, so it's really easy to keep track of. So that would definitely be a good strategy students might come up with. Another one would be to do the same thing as we did in the other one. Student might see that the 10 and the 2 could be multiplied separately. And so they would see that 99 times 10 equals 990, and they might think 99 times 2 would be a little more challenging, but 99 times 2 equals 198. And knowing that those two have been multiplied 99, they can then be added together. 9 plus 9 is 18, and 1 plus 9 is 10, 11. And they come up with the same answer of 1,188. So this one was actually a combination of the distributive property done mentally and also the standard algorithm of addition and multiplication. That will be another method. One other method for this one would be also drawing a model, but since it's such a large number, 99 times 12, they probably wouldn't draw an array because it would take a very long time. But one model that would work very well for this problem would be a partial products model. And the partial products model is especially effective in that it gets students thinking about the place values as separate. Much like we did with the 10 and the 2 here, it's going that a step further and doing it with the 90 and the 9 as well. So the 90 from 99 would go there, and the 9 from 99 would go here. So here we have our 10s, we have 9 10s, and here we have our 1s. And then for 10 and 2 to make 12, we have our 10 and our 2, and the students can see that these are much easier to do separately than all together. So one student might draw this type of model and see that 90 times 10 is 100, 90 times 2 is 180, 9 times 10 is 90, and 9 times 2 is 18. All they would need to do is line these up and add them together, which would give them 1,188. That would be another excellent model for students to solve this problem. Finally, our last problem that I've chosen for this number talk is 999 times 12. So, students would see that this is a bigger number and maybe a little overwhelming to some because it's got a lot of digits over here. But I'd ask students to think about it, think about what strategies they could use and what strategies from the other problems they could apply to this one. Or do they have a different one in mind? So, one strategy that students would probably think of since we've done it twice, and this is so similar, is to see that even though this is a really big number, it still can be made into an easy number by just adding 1. Like 9 and 99, if we add 1 to 999, we get 1,000. And 1,000 is an easy number to multiply by 12, which would give us 100, and it would give us 12,000. Yeah, 12,000. So 1,000 times 12 is 12,000. And how many do we subtract from 12,000? The 1 that we added to the 999 had to be multiplied by 12 as well. And so, to get back to the number we start with, we would need to subtract that 12, just like in the other problems, from our 12,000. And that would give us 11,988. So even though our numbers got bigger and bigger, every time we use this strategy, we still only had to subtract 12 ones from our big number. Another problem Another strategy that students might use to solve this problem would be just to see how big the number is, to be a little over. And so if a student is feeling overwhelmed, they might just set it up and solve it using the standard algorithm that they learned for multiplication, which would mean multiplying first the 2's place by each of these up above. So it'd be 2 times 9 is 18, 2 times 9 is 18, 19, 2 times 9 is 18, and 19. And then they would need to remember that this 10 being multiplied is a 10, in fact, and not a 1, which would mean adding a 0 to move over the place value. 1 times 9 is 9, 1 times 9 is 9, 1 times 9 is 9. And then adding these together, they would get 8. 9 plus 9 is 18. 9 plus 9 is 18, 19. And then 9, 10, 11, which would give them the same answer they got up here, 11,988. The main issue students might have with that one is remembering to move over the place value. Because the standard algorithm can be long, and it can be very easy also to mix up these carried over numbers. But that's another way students might want to tackle this problem, since it might be hard for their minds to wrap around it otherwise. But finally, another way that students could solve this problem would be drawing the model of a partial product table like they did for the last one. This time having 3 groups on the side here. Our problem is 999 times 12, so the 900 from that, they would see is not just 9, but 900 would go up here, and then the 90 and the 9 finally would go down there for the 1's place. And the 12, we wouldn't need this side over here, but the 12 would have a 10 here, like we broke it up in the previous problems, 10, and then 2 1's here for the 1's place. And these, they could easily multiply out across. 900 times 10 is 9,000. 90 times 10 is 900, and 9 times 10 is 90. 900 times 2, they could see that 9 times 2 is 18, and add those zeros would be 1,800. 9 times 2 is 18, and add 1 0 would be 180. And 9 times 2 is 18. Adding those all up together, and they would get 11,988. And that would be an easy way for students to keep track of all the place values that there are in this problem by writing it out in a table. And so wrapping up this number talk, that's what I would want to focus on. I would comment on the students who came up there and shared, and particularly the ones who were able to talk about place value, whether they were solving the problem using the standard algorithm and remembered to carry over that 0 from the 10 and how important that place value was, or if it was by using the where was it? Distributive property, when they separated the 10 and the 2 to make it easier, or if it was by using the partial product tables. And I would want to reiterate and applaud those students who did use place value and use this as a reminder for the others and go over this table as a strategy. That would be a really good way for students who are having trouble keeping that in mind, place value, as a way to easily do it in their head. Whether it's using a table like this or whether it's just thinking in their head, let's see, we've got 9, and that's the hundreds place. So we know that we have 900 times 12, and then we have 9 here. That's 90, so we have 90 times 12, and then we have 9 times 12. And they can solve all those individually. The important thing I would want to remind students of in this number talk would be the importance of place value. And we discussed the different way that place value was talked about and used in this number talk, and there were different ways. But I would definitely reteach students how to set up a table like this as a way to divide up not just one number, but both the numbers as an easy way to multiply out and add all together these numbers to solve the problem. Thank you.